The earthquake count beneath Montagne Pelée nearly tripled in a single week, from 45 to 124. This is the volcano that destroyed a city of 29,000 people in under 2 minutes in 1902. But the number that has volcanologists paying attention is not the count. It is a depth. 4.6 kilometers below sea level 1 week, 5.5 the next, in the corridor between the volcano's superheated water and its magma. Here is what that corridor is, what the observatory said it would be watching for, and what comes next. In the last 2 weeks of published monitoring beneath Montagne Pelée, on the French Caribbean island of Martinique, seismometers recorded 230 earthquakes. 228 of them came from the same shallow kilometer of rock they have been coming from for 7 years. They were tiny. None of them exceeded magnitude 1. Not a single person on the island felt any of them. 2 of them did not belong. In the week that ended on the 31st of July, one volcano-tectonic earthquake was located at 4.6 kilometers below sea level, slightly west of the summit domes. In the following week, ending on the 7th of August, the observatory logged another one. Same structure, same zone, roughly 900 meters farther down, at 5.5 kilometers below sea level. That is the story, not the count, not the swarm. One earthquake a week, arriving from a place these earthquakes do not usually come from, and getting lower each time. The Observatoire volcanologique et sismologique de Martinique, run by the Institut de Physique du Globe de Paris, publishes a bulletin every week listing how many events were recorded, how strong they were, and how far down they occurred. In each of the last two, buried in a paragraph about routine microfracturing, the observatory took the trouble to name a single earthquake out of more than 100 and tell you exactly how far below sea level it happened. Scientists do not single out one event in 100 for no reason. The raw numbers first, because the sequence is messier than the headlines suggest. In the week from the 17th to the 24th of July, the observatory recorded 45 earthquakes of volcanic origin. In the week that followed, from the 24th to the 31st, it recorded 124. That is a jump by a factor of nearly 3 in 7 days. And all of them were volcano-tectonic, rock fracturing, not fluid moving. None exceeded magnitude 1. The overwhelming majority sat between 0.7 and 1.7 kilometers below the summit. In the week from the 31st of July to the 7th of August, the count came down slightly to 109. 106 of those were volcano-tectonic, again, none above magnitude 1, again clustered in the shallow zone between 0.9 and 1.3 kilometers below the summit. The 4-week rolling totals tell you to be careful. 331 events in the 4 weeks to the 31st of July, 372 in the 4 weeks to the 7th of August. But in the 4 weeks to the 10th of July, before any of this, the total was 396, higher than either. This is not a clean ramp. It is a choppy sequence that happens to be rising right now, and anyone telling you the earthquakes are simply climbing is not reading the same bulletins. What has genuinely changed is the composition. The week to the 7th of August contained 2 event types that were completely absent the week before. 2 low-energy shallow hybrid earthquakes at 1.2 kilometers beneath the summit, and 1 long-period earthquake located east of the volcano at 26 kilometers down, magnitude 0.7. And running underneath all of it is a second signal that has nothing to do with earthquakes at all. Since May, the summit of the volcano has been physically moving. The observatory has measured ground displacement of several centimeters, consistent with an inflating pressure source about 1 kilometer beneath the summit. Over the 4 weeks to the 31st of July, that movement was running at about 1.2 centimeters per month. Over the 4 weeks to the 7th of August, it eased to about 1 centimeter per month. So the 2 headline signals are pointing in opposite directions. The earthquakes went up, the swelling slowed down, both measurements are real, both come from the same observatory, and they do not agree with each other. That contradiction is the honest center of this story, and it is worth sitting with rather than resolving. To understand why 2 earthquakes out of 230 matter, you have to know what is stacked underneath this mountain. Start at the top. From sea level up to about half a kilometer sits a shallow hydrothermal system. Hot water and gas circulating through fractured rock, the ordinary plumbing of any restless volcano. Below it, occupying roughly 0.2 to 5 kilometers below sea level, is the hydrothermal system proper, and it holds something stranger. The water down there is above 374 degrees Celsius and above 221 bar of pressure, which is the point at which water stops being either a liquid or a gas and becomes a supercritical fluid, something that flows like a gas and dissolves like a liquid and moves through rock in ways neither of them can. Below that sits the magma, Petrological work puts the shallowest storage zone at 5 to 8 kilometers beneath the summit. Studies based on mineral chemistry push it to 7 to 12 kilometers. There's also a volume between 6 and 9 kilometers below sea level that produces almost no earthquakes at all, and that silence is itself the evidence. Molten rock does not fracture, so a hole in the earthquake record is one of the ways you find a magma reservoir. Between the supercritical water and the magma, at roughly 4 to 6 kilometers below sea level, is a corridor. It is normally quiet. And it is precisely where those two anomalous earthquakes came from. One more piece of physics makes this specific. Somewhere around 5 kilometers below sea level, the rock beneath Montagne Pelée crosses what geologists call the brittle ductile boundary. Above that line, rock is cold enough and rigid enough to snap, which is what an earthquake is. Below it, rock is hot enough to deform slowly like putty, and it stops producing earthquakes at all unless something raises the fluid pressure inside it high enough to force a brittle break, where a brittle break should not be possible. The earthquake in the week to the 31st of July sat at 4.6 kilometers, just above that line. The earthquake in the week to the 7th of August sat at 5.5 kilometers, just below it. Not all earthquakes carry the same information, and at a volcano, the difference is everything. A volcano-tectonic earthquake is rock-breaking. It produces high frequencies, 5 to 30 hertz, with clean compressional and shear arrivals on a seismogram. It tells you something cracked. It does not, by itself, tell you that magma moved. The everyday swarm beneath Pelée, the shallow kilometer that produces almost all of these events, is a long-running family of repeating fractures inside the hydrothermal system, observed since at least the 1970s. A long-period earthquake is different. Its frequencies are low, half a hertz to 5 hertz, and it has no shear arrival at all because there is no clean snap to make one. What you are recording is a resonance, pressurized fluid ringing inside a crack, the way a pipe rings when you strike it. Across the entire 5-year study period that the observatory published last summer, only 17 of these were detected at this volcano, and only 9 of them could be reliably located. One of them turned up in a single week this month, at 26 kilometers down. That number is not arbitrary. 26 kilometers is the estimated depth of the moho beneath Martinique, the boundary between the crust and the mantle, the floor of everything. The observatory's own published work grouped its rarest events, the ones it associates with magmatic fluid movement, at 18 to 37 kilometers, straddling exactly that boundary. The third category is the hybrid earthquake, which is both things at once. A crack breaks, and then it rings. Shallow hybrids first appeared at Pelée in December of 2020, at the height of the seismic crisis, and then largely disappeared as the episode calmed. 2 of them showed up in the week to the 7th of August, at one point 2 kilometers beneath the summit. So in the space of 7 days, this volcano produced a shallow swarm, the return of hybrid events that had gone quiet for years, an anomalous fracture below the brittle ductile boundary, and a fluid movement signal at the base of the crust. And it gets more specific than that. In July of last year, the same institution that publishes those weekly bulletins published something else, a peer-reviewed study in the journal Scientific Reports, documenting 5 years of unrest at Montagne Pelée from 2019 to 2024. It is open access. Anyone can read it. Their model is that a limited volume of magmatic fluid rose into the crustal storage zones between 6 and 16 kilometers, raised the heat flux and the carbon dioxide load, and pressurized a hydrothermal system that was partly sealed at the top. That pressure is what has been generating the shallow earthquakes and the shallow swelling ever since. Then they wrote down what would matter next. Their words: over the period of unrest, the mechanism has enhanced the connectivity of the surface to the areas of crustal magma storage, a process that needs to be carefully monitored, given that final connectivity through this depth zone is required for, and often detected prior to, the onset of eruptive activity. Write that again with the last 2 bulletins in your hand. The depth zone they are describing is the corridor between the hydrothermal system and the magma. Final connectivity through it is what they say precedes an eruption. And, in each of the last 2 weeks, one earthquake has appeared inside that corridor, and the second one was lower than the first. That is not a forecast. It is the reason one event out of 124, and then 1 out of 106, is worth more attention than the other 228 combined. The same paper carried the timescale, and this is the number that should stay with you. From the destabilization of a magma reservoir to an eruption, the authors write, the timescale can typically be short, on the order of a few weeks to 1 or 2 years. That is what the observatory means when it says, in every bulletin, that the probability of eruptive activity in the short term remains low, but that an evolution of the situation in the medium term, weeks to months, cannot be excluded. It is not a prediction that anything has destabilized. It is a statement about how little warning this process gives once it starts. Here is where most of the coverage of this story goes wrong, and where the actual argument lives. Last autumn, this volcano was far louder than it is now. According to an answer the French Ministry of the Interior filed in the parliamentary record in June of this year, activity peaked across September and October of 2025, when an average of 4,750 earthquakes a month were recorded. Martinique media reported more than 4,000 tremors in September alone, against roughly 30 in a normal month. 4,750 a month works out to about 1,090 a week. The late July figure this year was 124 a week, so the current sequence is running at roughly 1/9 of the peak, not 1/38, which is the number you get if you carelessly compare a monthly total to a weekly one. Now here's the part that matters. The director of the observatory, Jérôme Vergne, described that autumn swarm to Martinique radio at the time. Some events reached magnitude 2, around the threshold where a hiker standing on the summit might actually feel one. The swarm exceeded anything in the observatory's catalog across roughly the 15 years the network has had its present capability. It was the loudest this mountain has ever been on an instrument. And he also said this: at that time there was no significant deformation, no surface phenomena, no new fumaroles, no dying vegetation appearing, and no change in gas chemistry, water chemistry, or spring temperatures. Every instrument except the seismometers read flat. Nothing happened. Compare that to now. The earthquake count is down by a factor of about 9 from that peak. But the summit is inflating at centimeter per month rates from a source a kilometer down, which the observatory's own director said was absent during the record swarm. And an anomalous earthquake has arrived from the corridor between the steam and the magma in 2 consecutive weeks. The count came down, and the other signals came up. That inversion is the real argument here, and it is far more defensible than saying the earthquakes are increasing. None of this is new behavior for Montagne Pelée. It has been in a documented state of reactivation since April of 2019, and understanding that history is what tells you whether one earthquake is remarkable or routine. Before 2019, this volcano produced about 19 volcano-tectonic earthquakes a month, 1,069 events between January of 2015 and April of 2019. Go back further to the record from 1995 to 2013, and the median was 10 events a year. 10. A single week this July beat that by more than a factor of 12. Then in 2019, it woke up. December of 2020 produced 493 events in a month, which the literature describes as a 25-fold increase over baseline, and the alert level was raised to yellow that same month. It has stayed yellow ever since. April of 2021 hit 614 events in a month. The whole episode has been migrating downward. The observatory's own description is a pattern of seismicity that deepened from top to bottom through time. Shallow fractures in 2019, tremor in 2020, tremor plus hybrid events in 2021, then hybrids and long-period events at greater depth in 2022. What has happened over the last 2 weeks looks like that same architecture replayed in miniature. Shallow swarm, then hybrids, then a lower fracture, then a lower one still, then a fluid signal at the base of the crust. There is a strong countercase, and it deserves an honest hearing. The swelling is slowing, not accelerating. The gas signal peaked in mid-2022 and declined through the 2 years after it. A pulse, followed by something close to steady state. The thermal springs on the flanks have never exceeded 36.8 degrees Celsius, a maximum set back in March of 2009. A patch of forest that died from carbon dioxide seeping out of the soil in 2019 has since grown back. Total earthquake energy in the first half of 2024 was below the pre-unrest baseline. There are also no fumaroles at the summit, and there have not been since 1970, which is why nobody measures sulfur dioxide at this volcano. There is nothing to sample. Every alarming signal here is invisible from the surface, existing only inside seismometers, satellite positioning receivers, and gas isotope ratios. That is unsettling and reassuring at the same time, and both halves are true. The authors refused to pick a side and said so in print. It is impossible to determine whether the current decrease in the intensity of the unrest will lead to a return to baseline, or whether the unrest could resume and evolve into more critical conditions. They added a sharper warning. The processes that matter can occur silently, at depth, long before any seismicity escalates. The loud signal is not necessarily the meaningful one, and the meaningful one can make no sound at all. All of this only matters because of what this particular mountain did on the 8th of May, 1902. At 2 minutes past 8 that morning, a pyroclastic density current came down the southwest flank and reached the city of Saint-Pierre. The city was destroyed in under 2 minutes. The flow was a suspension of gas and incandescent particles at temperatures up to 500 degrees Celsius, moving at over 200 kilometers an hour, hugging the ground as it came. Estimates of the death toll cluster between 28,000 and 30,000 people. It remains the deadliest volcanic eruption of the 20th century. Saint-Pierre was the commercial and cultural capital of Martinique. People called it the Paris of the Caribbean. It stopped existing in less time than it takes to read this paragraph aloud. 2 survivors inside the city are well documented, and the pattern they reveal is the whole lesson. Lugger Silberis, a laborer arrested after a fight 6 days earlier, was locked in a half-underground stone cell with no window, only a narrow slit in the door, facing away from the mountain. The masonry and the near-total lack of ventilation are what saved him. He was badly burned and found alive days later. Léon Compère Leandre, a shoemaker who lived at the very edge of the city, escaped with severe burns and wrote an account of it. That pattern is physical, not sentimental. The people who lived had rock between themselves and the mountain, or were at the outer margin of the flow. Being indoors did not help. Being upstairs did not help. Distance within the city did not help. A pyroclastic density current is not a fire you shelter from. It is a fluid that fills the space it enters. Today, pyroclastic flow runouts at this volcano reach about 10 kilometers, and the entire population of Martinique lives within 30 kilometers of an active volcano. One more thing in the historical record needs to be handled carefully. As early as 1889, the first signs of renewed activity at Montagne Pelée were noted. A fumarole appeared in a hole in the summit crater, with damaged vegetation around it. That hole closed up in 1899, and vegetation grew back over it. Fumaroles then intensified from June of 1900 until the first steam explosion on the 23rd of April, 1902. 15 days later, the city was gone. Now set the modern sequence beside it. Vegetation started dying on the southwest flank in late 2019, killed by carbon dioxide, seeping out of the soil at concentrations up to 7,800 parts per million, against a background near 400. The kill zone was confirmed by helicopter at the end of 2020, and it has since grown back. 13 years separated the first sign in 1889 from the catastrophe. The current unrest began in 2019, 7 years ago. That is a rhyme, and it is not a schedule. Nobody involved in this research presents it as a forecast, and neither should anyone else. By its own statistics, this volcano is not overdue. 2 to 3 magmatic eruptions per 1,000 years over the last 25,000 years gives a mean repose interval of roughly 330 to 500 years. And the last magmatic eruption ended in 1932, 94 years ago. There is also a distinction that will matter enormously if this escalates. Every magmatic eruption in this volcano's record was preceded by steam-driven explosions. But steam explosions have twice happened here on their own, in 1792 and again in 1851, with no magmatic eruption following. So an explosion at the summit would be alarming, would be the expected next step, and would still not mean 1902 was coming. The alert level on Montagne Pelée is yellow, which means vigilance. It has been yellow since December of 2020. There's no evacuation, no exclusion zone, and no eruption warning, and the observatory's formal position has not changed through any of this. The probability of eruptive activity in the short term remains low. What the observatory has said it needs is several more weeks of observation. The next weekly bulletin is due on or about the 14th of August, 2 days from now. It will answer the smallest possible question, and right now it is the only one that matters. Did the anomalous earthquake happen a third time? And if it did, how far down was it? A third occurrence, lower again, turns a coincidence into a trend. Nothing, or something shallower, largely closes the question. Watch the swelling rate too. If it keeps easing while the earthquakes stay elevated, the observatory's cautious reading holds. If it flattens or reverses while the count stays up, the two signals stop contradicting each other and start agreeing. And that would be a materially different situation. There is one more thing worth knowing, and it is the most useful fact in this entire story. The eruption that followed the 1902 catastrophe at this same volcano, the episode that ran from 1929 to 1932, was preceded by an evacuation. It produced dome growth and pyroclastic flows. The death toll was nothing remotely like the first one. The difference between those two events was not the volcano. It was warning, and what people did with it. Martinique's emergency plan pairs 12 communes in the north of the island with 12 reception communes in the south. An evacuation exercise in January concluded that a sea evacuation would probably work better than a road one, because roughly 256,000 registered vehicles sit on an island whose northern roads funnel through a handful of coastal routes. That is a documented weakness, and it is fixable. For now, nothing on the surface of Montagne Pelée is hot. Nothing has been felt. Nobody is being moved. But the scientists who watched this mountain told us, in print, exactly which signal would matter. And this month, that signal appeared twice in a row and moved lower each time. The next bulletin arrives in 2 days, and it will tell us whether that was a coincidence.